So good evening, everyone, or good afternoon, depending where you are. And as I promised, this is the first series of stream where we're going to look at Kubernetes and all the tools, all the systems that are around it. Today, this is the first stream that I do. This is just the time to set it up. We're going to look at kind. I know that there are people that told me to let them know where I was going to be live, so I'm going to ping them right now. So hopefully, at least we're going to have some sanity check on the stream. And I'm also going to probably send a message on LinkedIn. Okay, going live now. You can find me here for the next hour. So hashtag Kubernetes, hashtag kind. No thanks. Okay, and as promised, today we're going to look at kind. For people that don't know, kind is a project that is pretty much part of the Kubernetes project, and is their attempt to build a small tool to run Kubernetes locally and on CI. So what kind does, and you can see it in this little presentation down here, it's going to give you a command line tool that you can use to spin up a cluster real quick. And when I say real quick, it's actually in a matter of probably seconds. You can see it here, right? So why kind? We personally, but I also personally, we as a Nearform and me as Luca personally use these as a small cluster to test different tools. And the reason I use these is because it's the most lightweight solution that I've found. Or at least the one that allows me to quickly spin up even a multi-node cluster and be confident that I'm gonna have something ready real quick. I've tried many others. I tried Key3s, sorry. I've tried Minikube. I've tried many others, but being on Linux, this one is the one that is fastest for me. So let's have a look at what kind does for you. If you scroll down on the page, you see installation and use. You can install it in many ways. You can install it with Go directly if you want to, but since I'm on Linux, I have this installed with my package manager. So in this case, if I do pacman-ss kind, maybe it's not here. I probably installed with from R, but in general, I should have it installed already, and in fact, it's there. So kind, as you can see in here, supports a bunch of commands, and if we follow the installation guide in the kind main page, you have kind create cluster. That is the typical first command that you want to run. Now, since I don't remember if I already created clusters in here, the first thing that I'm going to do instead is try to list the cluster or get the clusters. You will see that those commands resemble quite well the kubectl commands or kubectl setup. So in this case, get cluster returns 2 clusters. I have my home lab cluster that, as I said, I use myself for experimenting, and I have the kind cluster. So kind cluster is the default cluster that kind creates. So if right now we're going to do we're going to run the commands the other way around, you can start deleting the cluster, and I'm going to get rid of, cluster -- name kind, and that is deleted. Obviously, I didn't need to pass the name because the default one is kind, but you will see that now if I do a kind get clusters, the kind cluster is gone. Now, Again, now if I try to do a kind create cluster, what it's going to do is it's going to create a kind cluster, right? So kind create cluster. We're going to give it a couple of seconds. It's totally the CNI at the moment. And here we go. We have a cluster created. And we can see that the cluster is there. And if I do a kubectl get cluster, actually kind get clusters, now the kind cluster is back. Let's see what else we can do with this cluster. So if we scroll down and we go to the quick start, you'll see that once kind cluster is created, this is the installation part, creating the cluster, here you go. You can possibly change the name. And this is something that I suggest you do, especially because otherwise, by default, you may delete the cluster that you want to create. So for today, let me delete the cluster we just created. And we're going to create a new cluster that is cluster name. And this is going to be streaming. It's good that it doesn't take long, so you can try these as many times as you want. As default, you can see that the nodes are created with 125.3. So kind supports obviously passing down the version of the cluster. And now if we want to see the context, we can run this command, kubectl cluster info, kind streaming, and you will see that here you go. The cluster is here. It's exposed to localhost, and this is the port, and core DNS is running on this port. Well, so what does kind do when I run this? What kind does, it doesn't do anything else than spinning up some Docker container. And by some Docker container, in this case, I actually mean, if I remember correctly, one Docker container. So if I do Docker PS, you will see that I have other things running, but if I do PS latest, there you go. You have a kindest node 125.3. And you can actually see that it is named streaming control plane. So that's all is needed. And this is already a cluster. So if I do kubectl get nodes, you will see that the control plane is actually one of the nodes is in ready state and is being up for 71 seconds. If I do a kubectl describe node, you will see that in this case it's going to give us more information, as you may already know. And one of the information is actually the, here you go. So where the CRI socket is running, and the other information that I was looking for is that is an MD64, is on Linux, and the host name is the host name that we've seen. So cool. Now we do have the first cluster running in my local machine, and obviously this cluster is not running with a lot of resources, right? But it's at all from all aspects a real cluster. Now, obviously, this may be not enough, right? With this, you can run basic command. You can probably get familiar with all the command that kubectl does. Let's see, for instance, what's in the what's running on the cluster. So if I do get pods-a, this will show us that there are multiple pods running in here. Let me see if I can do something to make it a little bit more readable. Here you go. Hopefully this is still big enough for you. Or I can also reduce the two window and make it a little bit better for you to see. Like this, or it's fine. It's fine. So now in here you will see that we have core DNS, we have etcd, we have the API server, the controller, the proxy, the scheduler, etc. Right? And plus there are other things running, the CANnet itself. Now we could also look at the fact that this is a real cluster. There are some namespaces by default, and there are some. Are there services? I never tested this. Yes, there are already two services by the default, cluster IP and kube system. But as we said, kind can create a single node, but a single node may not be enough. So let's suppose that we want to create a little bit more of a single node. Kind supports configuration, right? And this is what we're looking at here, advanced multi-node cluster. So let's suppose that we want a multi-node cluster. So the first thing that we want to do, we want to destroy this cluster. And as we say, we can do that. We kind delete cluster -- name streaming. There you go. And so kind get clusters. Now it should return only the home lab. And then if we go into code kind, yeah, I already prepared the directory here. And if I do beam streaming, or maybe let's just call it cluster.yaml, we can actually use this signature, this YAML here, right, to create a cluster. So if I paste this in here, so what this is going to do is telling you that it's a kind cluster that you should recognize the annotation. The annotation is the same they use on Kubernetes with the kind. API version is kind, and the nodes, there are 3 nodes, and there is 1 control plane and 2 workers. So another thing that you can pass in here, and it's weird enough that they don't tell you that you can pass it in here, is the name. You can actually specify the name of the cluster and this configuration. So if I go to configuration in here, and if I scroll down, you'll see that here you go. Name is part of the configuration. So what I'm going to do, I'm going to add that. And again, I'm going to call this name streaming. I'm going to save this. Now, to run these with the configuration, let's see how we do it. We do kind create cluster -- help, and there is -- config. I do a -- config, and I pass it a cluster.yaml. This time around, kind may take a little bit longer than what we thought. Hey, Rafael, nice to see you. Can you hear me right? Is the audio okay? So let's give it a second. Obviously, before it was very fast. In this case, it's creating more nodes, and that's why it's taking a little bit longer. So in this case, if I do a kube kind get clusters, you will see that now we have back the streaming cluster. And if I do a kind cluster info, a kubectl, sorry, cluster info kind streaming, there you go, the cluster is there. And if I do a kubectl get nodes now, you will see that we have 3 nodes. Now, again, those are 3 nodes from the Kubernetes perspective, but if we look at the kind point of view, or even if we look at the Docker point of view, you will see that if I do Docker ps -- latest, there is 1 node, but if I put -- sorry, I never remember so -- n3, the last 3, now we have three nodes, right? Where we have the streaming control plane, the streaming worker 2, and the streaming worker. And if you remember what's inside the config, the cluster configuration, we actually have worker, and control plane. So right now, what we have three Docker containers that represent the three nodes for the cluster. Okay. So what's next? Again, this is a full cluster. So kubectl get pods -a is going to show you again that there are even more stuff running. So you can see the difference here already, right? In the previous output, we had an API server, a controller, a scheduler, and then a bunch of core DNS. On this new output, we have obviously more kind nets because there are more nodes. In the previous one, we had one node. In this case, we have three nodes, so three kind nets. And then we have the same API server, the controller, but we have also three proxies, right? The scheduler is the same, and the etcd is the same. Can we deploy something in here, right? Can we actually deploy whatever, something that can run on the cluster? Of course you can. And let's take as an example, Argo CD. Argo CD should be okay. So if we go to Argo CD, I'm going to Argo CD just because I was using this today. We can actually run the commands to install Argo CD, and we should see that in a matter of minutes, maybe, Argo CD is going to be running in our system. So let's do this. Let's create a namespace first, and then if I do kubectl get namespaces, you'll see that Argo CD namespace is there, and we can run kubectl apply and install Argo CD in the Argo CD namespace very fast, as you can see. And now kubectl get pods and Argo CD. Here you go. We have the Argo CD installation running. We can even watch what's happening and see it live while it goes up. It shouldn't take long. Right now, it's probably pulling down the containers. And in a couple of minutes, maybe, we should see that the containers will be running. Okay, we already have the application controller, application set controller running. There you go. There you go. And so the next thing that we want to do, we want to try to get the port forward setup for Argo CD. I never obviously remember how to do this. So let me see if I can find it real quick. Port forward, here you go. So running this command, we should be able to expose the port. Obviously, this is not in my local machine, but is in a different machine, so I'm probably not going to be able to show it to you. The port is busy. There you go. Let me think of how can I show this to you. Yes, I can probably port forward from that machine. So if I do streamer -l and if I go here now in localhost, there you go. And we have Argo CD running. And this is the Argo CD that is running on the kind cluster, obviously, right? Because I've set up everything as we thought. The other thing that we need now is the password. And again, to get the password, I don't know if you know this, but Argo CD has the password generated, especially when you run it like this, right? When you install it with the default command, it generates an admin password in a secret. And let me see if they provide you with a admin password set up somewhere in here. Otherwise, I'm gonna have to remind myself how to run the command. And not biggie, we can do that. So let's see. Okay, never mind. I'm gonna use the command myself. So, and the command is something along the line kubectl get secrets. So I'm gonna show you that there is already Argo CD. There you go. There is already a secret there. That is the Argo CD initial admin secret. So this is the secret that we want. We're going to copy that. And sorry, I just realized that maybe that was a little bit small for you. And we're going to get that secret. So like this, you get the secret. And then we need the JSON path equal, is it like this? Dot data dot something, but I don't remember what. So give me 1 second. I should have it somewhere. Probably password. And there you go. Now, obviously, as you probably already know, this is a base64 encoded secret. So what we want to do, we want to do a base64 decode, and this is the password. So if I take this password here, and if I go in Argo CD, admin, and the password, I should be able to login. There you go. So as promised, kubectl get pods -a. Now we have Argo CD running on the cluster. And to ensure you that this is the right cluster, what we're going to do now, we're going to pretty much destroy the cluster and show you that the cluster goes away. So destroy or delete cluster --help. Can I pass the configuration? I can. So this is something that I remember that it was a problem for me at the start. What seems obvious to me is that should be able to delete a cluster based on one configuration. But then, if you think about it, let's suppose that someone is going to change this configuration before running the command. The name of the cluster may have changed. So maybe that's the reason why then I did --config on the delete command. Okay, so what we need is just to pass the name. So we're going to pass the name. And boom, as you can see, I just deleted the cluster from below Argo CD, and Argo CD is now down, it's not there anymore. Okay, so what we have seen up to now, we have seen that you can generate a quick cluster of one node, but you can also generate multiple nodes, right? A cluster with multiple nodes. And again, this is the cluster.yaml. I'll try to upload this configuration. Actually, probably not upload, but I'll probably link it somewhere. I'll probably add the link to the stream itself because it's quite a basic configuration. So let's see what else we can do with kind. We have another probably 20 minutes. We can go for another 20 minutes. So networking. Kind supports multiple networking, multiple IP families. So it has the support for IPv4 and IPv6 and even dual stack clusters. This is something that probably most of us won't need right away, but in the future, when you want to test multi-cluster, network or dual stack support for applications, it could make sense that you have it. For now, not really interesting for me. What else you can do? Oh yeah, you can pretty much make the API server listen on a different address if you don't want it to listen on localhost, and expose the API server on a different port. You can even set the subnet for the pods, again, if you want to mimic something that you have, or even the service subnet. Or even you can disable the default CNI if you want to do something different. So kind supports a lot of things. Probably most of those you won't need it while you set up the default configuration. But for instance, one thing that you may need is the extra mount. Let's suppose that you want to mount something inside a kind node to persist data, or you want to actually mount some files that you're going to load from your Kubernetes workload. That is something that you can do here. Another thing that can be very useful is the extra port mapping that you can use to forward to the kind nodes, right? And one example of this is port 80. Let's suppose that you want to expose something externally. This is how you do it, right? You do extra port mapping port 80. What else? Extra label. You can actually set up config patches. I'm not sure config patches. This is something that I've never done. I'm not sure what those are about. format kind run kubedm init, the first control plane node. We can customize the, okay, fantastic. So formally kind runs. Okay, so basically what we're seeing is that kind uses kubedm to build the cluster. And so if you want to pass down commands to kubedm, that's the way you do it. If you're not familiar with kubedm, kubedm is the tool that the Kubernetes community provides to create clusters. In one of the projects that I was on, we were actually using kubedm to build a cluster, and you pretty much can run kubedm in the control plane nodes and in the nodes themselves. And with these, or with a set of commands from kubedm, you can set up the whole cluster. kubedm is gonna download or pull the images for you, run the images with the right configuration, and you can even join the nodes with this setup, right? So you're gonna say kubedm if you're a node, join using this token on this control plane host. So what we're saying is that kind uses kubedm, and sometimes if you want to enable certain extra features, something that is behind the feature flag, like the enable emission plugins you can see in here, right? You need to pass down configuration to kubedm. And in kind, you can do that with this syntax. So you can actually pass kubedm config patches. This is something that I haven't done myself. Honestly, I mostly use kind for testing purposes and rarely need this level of customization. What instead is interesting are the ingress. You can set up an ingress controller with kind. So this is something that you want to do in case you don't want to pour forward, but you want to expose services outside. And kind supports contour, it supports Kong, and it supports Nginx ingress. So again, it's mostly about configuration, right? And this is the perfect example. You can say extra port mapping port 80 on host port 80 and container port 8443 on host port 443. And we can try that right now. And you can see that in here, we're already using the config patches to put the Nginx the ingress ready true, in one of the on the node labels. So if I take this one and I take this one here, let me do a different file. Ingress cluster YAML. There you go. Again, I want this to have a name. I'm still not sure why they don't pass the name by default. Maybe they want the name to be present or pass from the outside. So name kind ingress. And if I do kind create cluster -- name ingress cluster, we give it another couple of seconds while we're waiting for that. Okay, we are ready. And again, in this case, if I do kind get cluster, I just realized that I used 2 port that maybe I didn't want to use. What did I do? Vim ingress cluster.yaml kind get clusters. It's interesting that it's using ingress-cluster.yaml. What did I do? Oh, see what I've done. I use -- name instead of -- config. Delete cluster. So this is what you do if you're distracted where you run those commands, and I wanted to do config. Well, while I'm here, I'm gonna also change, because I just realized that I don't want to use those ports for the host ports, right? So allow the local host to make request ingress control over port 80 and 443. So if I'm not mistaken, then we want to do something like 80, 82, 80, 83. Is that right? And this is gonna be --config. This is create. Boom. Failure. Because port 8082 is already allocated. That was my fear when I was using 80 and 8443. So I'm going to do 483 and 84. And there you go. Let's see how it goes now. So what we're saying right now is that we want to expose the container port 80 to 8083 and the container port 443 to 8084. Again, if we do kind get clusters, you now see that we have a kind ingress. And if I do kubectl get nodes, we have a kind ingress control plane that is not ready. It's ready now. And in theory, if we look at that now and we do kubectl describe nodes, we should have a label in here that says that is an ingress ready true. Here you go. Now, let's keep following the guide. And let's suppose we want to do it with nginx ingress. If I run this one command, that let's see what it does. It's pretty much applying the manifest here. So before we do this, let's see what's inside the manifest. It's always a good idea to check that, even if, I mean, we're following the kind official guide, so there shouldn't be anything crazy in there. But if I do a curl, this one, and we pipe it to less, there you go. So what this is doing, it's making a namespace and then a service account. And then a role. What else is there? Another role. A cluster role. Another cluster role. A role binding, obviously you have to bind those to a service account. And a cluster role binding, because there's going to be the cluster, the service account nginx ingress. Okay, so it's building pretty much permissions and a config map. And finally a service. And the service is the service for nginx ingress. There's another service that is in port 443. So the first one, I suppose it was on port 80. There you go. Yeah, port 80 and protocol HTTPS 443. If it's a single stack AP family PV4, and this is what. Okay, it's a type cluster P. There you go. And then there is finally a deployment. Oh shoot! Why did I do that? There's finally a deployment. That is the controller itself. There you go. That's what I was looking for. That doesn't do anything else than run the nginx controller with some parameter. Blah, blah, blah. A job. What's the job about? Interesting. Oh, I see. Okay, another job. An ingress class. Okay, so it does create a bunch of things, and then a validated webhook at the end. Fantastic. Let's run it. And then it's telling us, once you run these, put yourself in the wait So you see if the pod controller is ready. If you don't know about kubectl, wait is allowing you to wait for resources based on a condition. In this case is ready pod. Do we want to wait for this? Kubectl get pods. So what we're looking at? We're looking at Nginx mission path. There you go. The Nginx controller is creating at the moment. It says that it's going to wait for 90 seconds. I'm starting to doubt that it's going to be ready in 90 seconds, but maybe, hey, it's just me not trusting the system enough. 80 seconds, still creating. $94. Obviously, I started the wait a little bit after the thing started creating. Boom, timeout. It went out because obviously it's taking more than 90 seconds. Will he ever come up? And ingress Nginx. Ooh, okay. Failed to set up the network sandbox. Able to set up DNAT. Okay, this is interesting. Apparently, that thing is gonna fail. Is this something? I've never seen this. No load multi-port, no such file directory. Let's see what this is saying. There's something we can find online. Probably not gonna have time today to debug this, but maybe that's a good thing for next time. Okay, this is random AP table, so it's not gonna return this. What we want, kind. See, this is what's gonna happen now. Okay, there is an issue there. There is actually an issue on kind that is closed though. Why is it closed? No, that's not my case, I believe. Okay, you know what? It's not gonna be for today. So tune in next time if we want to see how kubectl, how ingress Nginx works with kind, because I'm not gonna fix it tonight. Okay, but I guarantee you that I had that working at one point. I'm actually thinking that it's possible that the other cluster has something to do with this, but why would they fail with multi-port? Able to set up DNAT, that's interesting. Okay, I don't know. Delete cluster dash name. Actually get clusters, let's see. Kind ingress, that's what I'm looking at. Delete cluster name. Kind ingress. There you go, we're back to square one. And we didn't have the ingress working. You can also set up load balancers like MetaLB if you want. You can set up a local registry and a private registry. You can run it rootless, or you can run it using WSL2. And in theory, you can even make it work offline. But again, not for today. I'm already at time. We have another 7 minutes, and honestly, I'm not feeling like starting anything new or any new experiment. Okay, I hope you enjoyed the first streaming. It was very basic. We just looked kind. Again, if you want to find kind, you will see that I'm going to touch these on the streaming itself when I release this video, if I release this video, or I'm going to tweet about again about this. Thank you for watching, and I'll see you next time, I suppose. Bye.